Hello, my name is Brian Day. I'm a scientist working at NASA's Solar System Exploration Research Virtual Institute, where I study the Moon, Mars, and other objects in our solar system. It is my great pleasure to get to work with Emily Law and the other members of NASA's Solar System TREX team in producing online portals that allow you to explore other worlds like Mars.
Hello, I'm Emily Law from NASA Jet Propulsion Laboratory. I have the pleasure to work with Brian Day on the Solar System TREX project, responsible for the development and operations of the sets of the TREX web portals, including Mars TREX. Today we are going to take a tour of Mars, looking at some of its amazing landforms, examining where we have been, and looking ahead to where we want to go in the future. We will look through the eyes of many different instruments orbiting Mars, and we'll end by showing how you can use NASA tools to conduct your own Martian explorations.
If you look up in the evening sky during the fall of 2020, you'll see Mars shining bright and red in the east. The red color comes from rusty dust on its surface. This close-up shows the reddish dust and gray areas of exposed rock. What you don't see is any liquid water. Mars does have ice caps at its poles, but any surface water we find is frozen. Mars's surface today is a complete and total desert. There are no lakes or streams to be found anywhere, but it wasn't always that way.
Let's change to a laser altimeter view, a device that precisely measures and shows the ups and downs of the surface. We color code the view with blue being the lowest areas, green higher, and red higher still. In this view, we can see many ancient and now dry river channels that flowed into bays that then open up to what was once an ocean. This is important because here on Earth, wherever we find water, we find life. So if Mars was once covered in water, could there have been life?
Mars calls to us to explore it. We have many questions about the red planet. Why has it changed from a warmer, wetter world to the cold, dry planet it is today? What caused those changes? Can Mars teach us important lessons about caring for our environment here on Earth? Was there once life on Mars? And could it possibly still have life today? If so, how might that life compare with life here on Earth? Someday you and your friends might actually get to be able to live and work on Mars. You might get the exciting opportunity to find the answers to these questions. So let's take a close look at Mars. Let's examine this amazing planet together.
Like the Moon, Mars has impacted craters where asteroids crashed violently. These craters cover much of the very ancient highland area of Mars. But the younger sediment-filled lowlands have had their craters erased. Mars has many fascinating landforms. This is Valles Marineris, Mars' Grand Canyon. And when we say grand, we mean really grand. If it were here on Earth, it would stretch all the way across North America. There's a huge canyon for a world with only half Earth's diameter. Like the Grand Canyon here, Valles Marineris is a network of valleys. Its walls stand as tall as Earth's tallest mountains and are marked with the Titanic landslides.
Flying west and north, we encounter the broad, rounded, massive Tharsis volcanoes. The greatest of these is Olympus Mons. It stands almost 3 times taller than Mount Everest and covers an area almost as big as Washington State. Here we use NASA's Mars Trek portal to fly into the crater of the solar system's greatest volcano. Huge, massive flows of lava rock extend for hundreds of kilometers from the mountain's base. Other volcanoes of the Tharsis group are true giants too, dwarfing volcanoes we find on Earth. Even Tharsis's smaller volcanoes would be considered immense here. Mars's volcanoes aren't limited to the Tharsis region. On the other side of the globe, we find the gigantic Elysium volcanoes. Scattered across Mars's surface, we see many volcanoes, most very broad, with large summit craters. South and east of the Elysium volcanoes, Mars's crust is broken by giant cracks. These are the Cerberus fossae. Recent measurements have shown this area to be the source of Marsquakes and is the first active fault zone we have found on Mars.
As of late 2020, our robotic landers and rovers have successfully touched down on 8 different locations on Mars. Let's take a look at these missions and their sites. Viking 1 consists of an orbiter and a lander. The lander was the first spacecraft to successfully land and operate on the surface of Mars. Service operation ran from July 20th, 1976 to November 13th, 1982. It conducted soil analysis and searched for evidence of life.
Viking 1 landed on the plains of Chrysi Planitia. This area is near where a great river channel apparently flowed into what may have been a large bay. As we fly over the plains, we can see lots of signs where the land was shaped by flowing water in the distant past.
Viking 2 consists of an orbiter and a lander. Service operation ran from September 3, 1976 to April 11, 1980. The lander conducted soil analysis and searched for evidence of life.
The landing site for Viking 2 was Utopia Planitia. This vast plain is part of the Borealis Basin, an area that may have once been the floor of a great northern ocean. Aside from being a fascinating site from a scientific point of view, the flat, smooth plains made for a safe-looking choice to target a lander.
On July 4, 1997, NASA's Mars Pathfinder mission carrying the Sojourner rover touched down in Ares Vallis. This was the first rover to explore Mars. Ares Vallis is one of Mars' greatest flood channels where, in the distant past, flowing water craft dramatic erosional features. The Pathfinder mission touched down near the mouth of the channel, where smooth terrain offers safe opportunity for landing.
On January 4, 2004, Spirit, also known as Mars Exploration Rover A, landed in Gusev Crater. One of 2 robotic rovers in NASA's Mars Exploration Rover program, Spirit was designed to explore the geology of Mars, look for evidence for the presence of liquid water on Mars's surface in the past, look for geological clues to the environmental conditions that existed when water was present, and study whether those environments were suitable for life. Gusev Crater measures 166 kilometers across and was formed by a large meteoroid impact 3 to 4 billion years ago. It was once a crater lake filled by a river flowing in from the south. The river valley, Ma'adim Vallis, stretches for about 700 kilometers south from Gusev Crater. Its wider sections measure over 20 kilometers across, and it reaches 2 kilometers in depth. Spirit's landing site is seen in the lower right of our map. In this view, we fly north along the river valley and see where it emptied into the crater. We can imagine what Gusev looked like long ago when it was filled with water.
Here we see the path of Spirit as it rolled across the floor of the crater and up into the Columbia Hills within the crater. Looking down on the hills, we see the path of Spirit. But we can also see numerous dark paths across the landscape. What caused those? It turned out that these are the paths of the dust devils or whirlwinds. They leave dark paths where they clean the lighter dust off the darker underlying rock.
On July 25, 2004, Opportunity, also known as Mars Exploration Rover B, landed in Meridiani Planum. Opportunity revealed beds of sedimentary rock, salt deposits, and minerals including gypsum and jarosite that all told the story of how liquid water did indeed exist on the surface here in the distant past. Opportunity's roving journey took it across what was apparently once the floor of a shallow sea. It traveled far and long, eventually ending its journey along the western rim of Endeavour Crater, seen here. On May 25, 2008, NASA's Phoenix probe touched down in Mars's northern plains known as Vastitas Borealis. The Phoenix lander's job was to study the history of water on Mars.
Phoenix helped answer at least part of the questions of where Mars water went. Scooping the ground with its shovel in its far northern location, it found ice in the forms of permafrost just beneath the surface of this frigid desert.
Looking down from orbit, we can just make out the Phoenix lander. Below and to the right, we can see its heat shield that it discarded after its fiery plunge through the atmosphere. Below and to the left, you can see the parachute it used for the latter part of its descent.
Curiosity landed in Gale Crater on August 6, 2012. With a diameter of 154 km and a central peak of 5.5 km tall, Gale Crater was chosen as the landing site for the Mars Science Laboratory Curiosity rover. The choice was based on evidence from orbiting spacecraft that indicate the crater might have once contained large amounts of liquid water. The central peak, Mount Sharp, exhibits layer rock deposit rich in sedimentary minerals that require water to form. On its journey, Curiosity is finding ancient stream beds and lake beds. Its path has taken it along great fields of sand dunes and up the lower slope of Mount Sharp.
Mars InSight landed in Elysium Planitia on Mars on the 26th of November 2018. This was the first spacecraft to land on Mars designed to specifically study the interior of Mars. It is measuring the heat coming from inside Mars and measuring Marsquakes. From its location south of the Great Elysium volcanoes, InSight is detecting and localizing quakes on Mars. It is through these measurements that we learned about the quake activity in the Cerberus Fossae. On its way to Mars right now, the Perseverance rover is scheduled to land on February 18, 2021. Its destination is Jezero Crater, an ancient crater lake that measured 49 kilometers or 30 miles across. Perseverance will study how suitable the ancient environment on Mars might have been for life. Soon there will be another landing site added to our map. Jezero Crater was filled by rivers entering from the west and the north. Their dry beds can still be seen today. Water drained from the lake through a channel in the east on the right of this view.
Here we fly along the inlet channel as it crosses through the rims of Jezero Crater. As the river entered the lake, it dumped its loads of sand, mud, and gravel into a delta deposit on the floor of the lake. Perseverance will study this deposit and its contents. Perseverance will carefully collect and store particularly interesting samples. NASA and the European Space Agency are now working on plans for a mission that would follow on after Perseverance. The Mars sample return mission would make another trip to the Jezero Crater, gather these samples collected by Perseverance, and return them to the Earth to be studied. Looking further ahead, we are now identifying possible landing sites for human mission to Mars. Over 40 have been found so far, and we are counting to add to the list. Not surprisingly, some of these sites are in Mars Grand Canyon, Valles Marineris. Its walls expose the geologic history of the planet. Across its floor, we see sand dunes and deposits from the floor of the ancient lakes and once occupied the valley.
At the western end of Valles Marineris, we have another area of interest. Noctis Labyrinthus is a complex maze of ridges and valleys on the border between Mars's greatest canyon and volcanic provinces. Zooming down along the shoreline of Mars's former northern ocean, we see an ancient degraded crater. Channels cut through its walls. Water clearly played a role here. As we get closer, we see strange, smooth, pillowy areas along the inner rim of the crater. Getting closer, we see that these are actually dust and dirt-covered glaciers. There are a great many of these mid-latitude debris-covered glaciers on Mars. They are another piece to the puzzle of where Mars's water went. McLaughlin Crater was another ancient crater lake, but it wasn't filled by an inflowing river. Instead, it was filled by groundwater seeping up from below. While there is no more liquid water on the surface of Mars today, scientists wonder if there could still be water underground, and if so, if there might be life beneath Mars's surface. A field of crescent-shaped sand dunes marches across the crater floor, revealing the direction of the prevailing wind. If you were to look up in the sky from the surface of Mars, you would see something amazing. Mars has not one, but 2 moons in its sky. Right now, the Japanese Space Agency is planning a robotic mission called the Martian Moons Exploration that will land on the surface of the closer, bigger moon Phobos, and then fly close to the smaller, more distant moon Deimos. Some people think Phobos could someday become a natural space station for us in orbit around Mars, making it easier to conduct future exploration of Mars.
This tour of Mars was provided using NASA's Mars Track online web portal. You can conduct your exploration of Mars and other worlds through the Solar System Track website at track.nasa.gov. Here's a quick intro to using Mars Track. You'll be offered an online tutorial when you first enter the site. Using Mars Track, you can view the surface of Mars through the eyes of many different instruments aboard many different spacecraft, as we've been doing today. You can pan and zoom to any surface feature you want. We'll zoom into this crater. One question you might have is, how big is that crater? Measuring a distance is as simple as drawing a line in Mars Track. Here we see the crater is almost 160 kilometers across. Next, you might wonder how deep the crater is. Again, it's as simple as drawing a line. The elevation profile tool lets you measure the heights of the mountains and the depths of valleys and craters. You can also use Mars Tracks to draw a bounding box around any landform you like. Mars Track will then generate a file you can send to your 3D printer. Mars Track also lets you draw a path anywhere you like on the planet's surface. It will then give you a QR code to scan into your smartphone. Put your phone in a pair of inexpensive cardboard-compatible goggles, and you will fly whatever path you drew in virtual reality. Switch into Mars Track's 3D globe view, and you can interactively fly across Mars terrain, just as we have been doing in this tour. So continue your own exploration of Mars and more with NASA's Solar System Tracks at tracks.nasa.gov.